Hello, here's another episode of Maths with a Black Rat. Sorry, Zeke, you have to move, baby doll. Okay, so today we've got a question that goes like this. Suppose that you've got a wooden flagpole. I'm drawing it lightly because tragedy is going to strike in a minute. So here's our flagpole, okay, and it was 25 feet tall, okay, initially, but then there was a storm and it broke. And it broke, I don't know, maybe about here, and the top bit tipped down to the ground. Here's your flag all crumpled up on the floor. Okay, and we know that it's a distance of 5 feet from the tip of my flagpole to its base. And the question is, I want to know how long each of those broken pieces of flagpole are. So we have to make some assumptions. One assumption is that the ground is level, and the other assumption is that the flagpole was erected to be at right angles to the ground. If we don't make those assumptions, we can't do the question. Okay, these sorts of questions are excuses to make you practice Pythagoras and trigonometry. So here's our assumptions. Okay, so the flagpole altogether was 25 feet high, and its tip goes down 5 feet from the base. Okay, so this is what I'm going to do. I'm going to say, okay, I'm going to assign a variable to one of these two pieces. So it doesn't matter which you pick. I might pick this side and call it length x. Now that broken bit and that broken bit altogether make 25 feet. So this length is going to be 25 subtract x, and that's the key to this question. So let me run that by again. This broken flagpole, here's my flagpole. Here's the flag, looking sad. Okay, here's the flagpole lying on its back. Okay, so the whole thing is 25 feet. I hope that's in, is that in camera? I hope that's in camera. Okay, and if it breaks right here, and I call that length x, then that length has to make up the rest of the 25. I don't need to give it a new variable. I just know that it's the difference from 25. Okay, so that's my key. Now I go back and I see that, well, here's our right triangle, and I know this side is x, this side is 5, this side is 25, subtract x, and I can set up Pythagoras. So Pythagoras goes like this. Let me grab some color. Pythagoras says a squared plus b squared equals c squared, where c is always your longest side, your hypotenuse. Okay, it doesn't matter who you call a and b. They're just the two shorter sides. So this is going to be all algebra style, right? So I've got 5 squared, that bit's okay. X squared, that bit's plain and tidy. But then c squared is that whole phrase, 25 subtract x, quantity squared. Now it's an algebra question. Now the algebra question is solve for x. That will tell me that bit, and then I can figure out the other bit that broke. Okay, it's a cheap excuse to make you do algebra. All right, so let's shake it out. 5 squared is 25, plus x squared on the left, and I have to multiply out the brackets. And if you'd rather see that, I'll do it over here. If you'd rather see that as two pieces, so 25 subtract x times 25 subtract x, by all means, scribble it out to the side and then put it back in your equation. I do that sometimes for tidiness. Okay, so 25 times 25 is 625. If you don't know that, use your calculator or do it out by hand. I know it because I've been doing this for decades. You just end up remembering the numbers. Okay, 25 times 25 is 625. 25 times x, that's a subtraction, so let's subtract 25x. Moving on, that's a subtract x times a 25, that's another subtract 25x. And I just have room to say subtract x, that's going to give me a plus x squared. And that's going to collect up as 625 subtract 50x, add x squared. And if any of this is sticky or uncomfortable for you, drop me an email and I can talk this through in lavish detail, but I don't want to do that in the middle of this problem. Okay, so I'm assuming that you're comfortable with this. If you're not comfortable, let me know. So I'm going to put this back into my equation. So that's 625 subtract 50x plus x squared. Now there's some convenience that happens here. I immediately notice that I've got plus x squared on both sides of my equation. So I can subtract x squared from both sides. You're allowed to do that. You don't have to know what the number x is. You can still subtract the quantity x squared from both sides. That's going to clean up really nicely. So on the left, I've got 25. Here's my equal sign. And that's going to leave me with 625 subtract 50x. Okay, so I have x happening in one place. And I think what I might do, many roads lead to Rome. There's no one way to solve this. There's a few options here, but I'm going to do this. I'm going to add 50x to both sides just to not have to deal with that subtraction. So I'm going to say 25 plus 50x equals 625. Okay, then I'm going to subtract 25 from both sides. That's going to give me 50, sorry, scoot that up a little, 50x equals 600. Again, these are really tidy numbers, so the arithmetic turns out easy. And now I divide both sides by 50. So x equals 600 divided by 50. If I shake that out, well, I can divide top and bottom by 10. That's going to give me 60 divided by 5. And that's 12. 12 times 5 is 60. So x shakes out as 12. Now, I don't stop there. I have to go back to the original question and say, what was it I wanted to know? And the question was, I wanted to know the lengths of both pieces of this flagpole. So I know that one piece is, that's my x, one piece is, small camera, one piece is 12 feet, and the other piece is 25 subtract 12, which is, help me out here, that's 13. Okay, so one piece is 12 feet and the other piece is 13 feet. I'm done. The end. Okay, so you might be wondering, how come it shakes out so exactly? Didn't it just break at a random piece in the middle? And the answer is, if it had broken any shorter, then your flagpole would have gone out a lot further from the base. If it had broken off really high, this little piece might not even have reached the ground. So where it breaks, because we assume it's all rigid and not bendy or saggy, this distance from the tip to the base really does determine where in the middle it snapped. So there you go. What country was this flag? I don't know. What flags can I easily draw? Marshall. No, it's not the Marshall. Is it the Marshall Islands? No, or is it the Seychelles? I think it's the Seychelles. Has a really cool flag that goes like that. And there's loads of different colors. We'll say it's the flag in the Seychelles. Okay, there you go.